Welcome to Unit 6, Lesson 1. Triangles, triangles everywhere. What is a person to think? The focus of this lesson is to understand the relationship between angles, triangles, and polygons and their attributes. There are three terms you need to understand as we begin talking about angles. The first is a ray is a part of a line that has an end point and continues forever in one direction. Here is our end point, and here is our arrow indicating that it continues on. A line is a straight path that goes on forever in opposite directions. Two arrows in either direction identify a line. A line segment is a part of a line that has two endpoints, 1 and 2. An angle is defined as two line segments or rays that meet at an end point. Here is our end point, and here is our two rays in this case, and two line segments here. Here's our end point. The angle is created by the section in between the two rays here and the two line segments here. I've identified a triangle, so you can see that a triangle also has three endpoints, and it has three angles as well. Angles are identified in three ways. An acute angle is less than 90 degrees. A right angle is two perpendicular lines, and they are exactly 90 degrees. And an obtuse angle is an angle greater than 90 degrees. Let me demonstrate this to you with a protractor. Here is two angles that are exactly perpendicular, or two rays that are exactly perpendicular, and they form a little square right here. And this is exactly 90, and it is a right angle. If you look, a line is a straight line is 180 degrees. It's just exactly straight. Anything greater than 90 degrees is an obtuse angle. It is going to be greater than, and do you see the angle that is formed here? Anything smaller than 90 degrees is going to be an acute angle, smaller than 90. So let's just review really quickly. A ray is a line that it has one endpoint and continues forever in one direction. Now, two line segments or two rays that meet together at an endpoint can form an angle. Here are our angles. A right angle is two lines, segments, or rays that form an exact 90-degree angle and square. They're perpendicular to each other. Now, some angles are smaller than right angles, and some are larger. Here's a larger one, here's a smaller one. Let's look at these angles that are named with a letter in the corner. So here's V, W, X, Y, and Z. I've identified, so you can look at their attributes and see if you can understand which of the angles are right angles. There's only one identified as a right angle. These are two perpendicular lines, and we have a square built in the middle. W is the only one that has that attribute of right angle. Which of the angles are smaller than right angles? X and Y are the only ones that are smaller than 90 degrees. You can tell if you simply visualize a right angle. Which of the angles are larger than a right angle? V and Z. Now, triangles are identified by the types of angles that are represented within them. So the first ones are right angles, and we can tell that by these perpendicular corners that form a square. 1, 2, 3, 4. These triangles in this section are all smaller than right angles. These are all acute, have acute angles. In these triangles, they are larger. They have one angle that is larger. 1, 2, 3, and 4. Now let's look at K, L, and M and use these to answer these questions. Number 4 says, which triangle has one right angle? Remember, a right angle is always perpendicular lines that meet at the end point and form a square. This is the only triangle that has a right angle. M. Which triangle has 3 angles smaller than right angles? Well, L has a larger angle than a 90-degree angle, but K is the only one that has 3 smaller angles, smaller than a right angle. And L, it asks the question, which triangle has one angle larger than a right angle? And the only one with that attribute is L. Triangles can be defined in 2 ways. We've already talked about the angles. And now we're going to talk about the length of their sides. They are identified in 3 different ways. A triangle with 3 equal sides is called an equilateral triangle. It has 3 sides that are measured from endpoint to endpoint exactly the same. An isosceles triangle has only 2 sides the same, 1 and 2, 1 and 2. A scalene triangle has no sides of equal length. Use the triangles M, N, and O. Write M, N, or O, then complete the sentence. For time's sake, I've already identified this, but I need you to understand the attributes and understand how only one can fit in this category. So look again at M, N, and O. It says triangle blank has one right angle and has 2 sides of equal length. Well, the only triangle that has a right angle is M, and it has 2 sides of equal length. Let's check and see if our answer is correct. M and 2. Now let's look at this last problem. It says use triangles P, Q, and R. Write P, Q, or R, then complete the sentence. It says triangle R has 3 angles smaller than a right angle and has 3 sides of equal length. Let's see if we're correct. Now it has, R has 3 angles smaller than 90. That is correct. And has 3 sides of equal length. It is an equilateral. And we are correct. We've already discussed the 3 attributes of sides and angles. In this particular page, it identifies 3 different things or attributes in the length of their sides, and the first one is 3 sides of equal length. These are equilaterals. Our second section is 2 sides of equal length, and those are isosceles triangles. It's a little distorted on the page. And the last area is triangles with no sides of equal length, and these are called scalene. Now let's look at our little practice down here, 7, 8, and 9. It says use triangles B, C, and D for exercise 7 through 9. Which triangle has 3 sides of equal length? The only triangle in this category that identifies 3 equal lengths is this equilateral, and it is C. Which triangle has 2 sides of equal length? D if you look at their attributes, D is the only one with 2 sides of equal length. That would leave B to be a triangle with 0 equal length sides. I would like you to practice using 10, 11, 12, 13, 14, and 15, and you'll use these and see if you can identify the angles and the attributes of the length of sides. Now, polygons are also part of our learning exercise, this lesson 1. A polygon is a flat closed figure made up of line segments that do not cross each other. So let's look at 16 through 23 and see which ones fit in this category. Okay, line segments meet because they are a closed figure. So 16 is a closed figure and it fits in those attributes. Now let's look at 17. It is a closed figure, but it says it is made, it does not cross each other. So 17 does not fit. 18, is it a closed figure with no area that crosses? Yes. How about 19? It is a closed figure. How about 20? Now, is 20 line segments? No. It is squiggly lines. That does not fit our categories. 21 is a closed figure. 22 is not a closed figure. There's an open section right here. And 23 is not a closed figure either. Now there's a term for the different kinds of polygons. There's a term called concave or a term called convex. A concave polygon exists if the line segment with the endpoints is outside of the is inside the endpoints, and a convex is outside the line segments. I've done 2 here. This particular polygon is a convex polygon. No sides exist within the line segment endpoints. 25 has one section that exists within the endpoints, so that is called a concave. I'm going to leave 26 and 27 open so that you can try those yourself and see if you can identify which one is convex and which one is concave. The last area we're going to discuss is polygons are also identified for the number of sides that they have. If you identify endpoint to endpoint on the lines, you can identify different kinds of polygons by the number of sides. If you count 1, 2, 3, 4, 5, 6, this is a polygon with 6 sides, and it is identified as a hexagon. And a polygon that has 3 sides, 1, 2, 3, is a triangle. I'd like you to finish this or read through it and see if you can understand the number of sides and how it identified by its number of sides. That concludes our lesson number 1 of Unit 6. Good luck, and we will talk about this in class. Thank you.